When I need the term sine and cos, I can express cos in terms of sine. So therefore, I know the formula of cos 2x as 1 minus 2 sine square x. We know the formula of tan 2x as 2 tan x divided by 1 minus tan square x. Here conversion becomes very important. This can also be expressed in many more identities, but this is one of the identity of cos 4x where we can derive using cos 2x formula. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we are going to take up few more identities on multiple angles, and we'll see how we will transform a function of one trigonometric function into another in terms of sum or product using transformation formula. So let's take up few multiple angles before going to transformation formula. Prove that sine 3x is equal to 3 sine x minus 4 sine cube x. We have proved for sine 2x, cos 2x, tan 2x using the formula of sin x plus y, cos x plus y and tan x plus y formula. So here also we will use the compound angle formula only. So that is, we will take sin 3x as sin 2x plus x. Now here we are going to use sin x plus y formula, but here in the place of x you have 2x, in the place of y you have x. Just convert the formula in the form of sin x plus y. So this can be written as sin 2x cos x plus cos 2x sin x. Look at the right hand side here. Here all the terms are in sine only. That's why other than sine function, if you get any other trigonometric function, convert it into sine function. We know that sin 2x is 2 sin x cos x. Using multiple angle formula, we have one more cos x outside here. Plus cos 2x can be written in four forms. In that, cos 2x can be written as 1 minus 2 sine square x, where it has only sine square term. So that's why I will use 1 minus 2 sine square x formula for cos 2x, and outside we have here sin x. Now multiply, we have here 2 sin x, cos x into cos x becomes cos square x, 1 into sin x becomes sin x, minus 2 sin square into sin become sin cube x. Now here cos square x can be written as 1 minus sin square x. Using the identity cos square plus sin square is equal to 1. So now here sin x minus 2 sin cube x. So next we will multiply it again. We will get 2 sin x minus 2 sin cube x plus sin x minus 2 sin cube x. So 2 sin x plus sin x becomes 3 sin x. Minus 2 sin cube x minus 2 sin cube x become minus 4 sin cube x. So this is our sin 3x. One more identity of multiple angle formula in terms of 3x. Next, prove that cos 3x is equal to 4 cos cube x minus 3 cos x. So here cos 3x can be written as cos 2x plus x. So therefore here this is in the form of cos x plus y. So cos x cos y means here cos 2x cos x minus sin x sin y, that is sin 2x sin x. Now we know the multiple angle formula of cos 2x in terms of cos only, that is 2 cos square x minus 1, because in the right hand side we have the terms only in cos. So next sin 2x is 2 sin x cos x into sin x. Now here we will get 2 cos square x into cos x become 2 cos cube x minus cos x minus 2 sin x into sin x is sin square x into cos x. But sin square x here can be converted into 1 minus cos square x. So therefore here we can write sin square as 1 minus cos square x into cos x. Next we have 2 into 1 as 2, minus into minus as plus, 2 cos square x into cos x become 2 cos cube x. Now 2 cos cube x plus 2 cos cube x is 4 cos cube x minus cos x, and here 2 cos x has to be written, minus cos x minus 2 cos x is minus 3 cos x. So this is the identity of cos 3x. Next we have tan 3x, 3 tan x minus tan cube x divided by 1 minus 3 tan square x. Again we will express tan 3x as tan 2x plus x. Use the formula of tan x plus y. So this can be written as tan x plus tan y means tan 2x plus tan x divided by 1 minus tan 2x tan x. But we know the formula of tan 2x, that is 2 tan x divided by 1 minus tan square x. So plus tan x we have whole divided by 1 minus 2 tan x divided by 1 minus tan square x into tan x we have. Now here taking LCM we will get 2 tan x here plus tan x into 1 minus tan square x means we will get tan x minus tan cube x whole divided by 1 minus tan square x whole divided by, here 1 into 1 minus tan square x is 1 minus tan square x. Next here we have minus 2 tan x into tan x is tan square x whole divided by 1 minus tan square x. So denominator is common, so we can cancel. Now 2 tan x plus tan x is 3 tan x minus tan cube x whole divided by 1 minus tan square x minus 2 tan square is minus 3 tan square x. So this is tan 3x. Next we have tan 4x. So here 4x is again a multiple of x, 4 into x, a multiple angle again. Now here tan 4x, I will take it as tan 2 into 2x. We know the formula of tan 2x as 2 tan x divided by 1 minus tan square x. But in the place of x here, you have 2x. So replace the formula as tan 2x only. Again you will get 2x. Again you will substitute tan 2x formula. So therefore here we have tan 2 into x. So that means 2 tan x. In the place of x we have 2x. 1 minus tan square 2x again, because in the place of x we have 2x. Now again substitute the formula of tan 2x. So we will get 2 tan 2x is 2 tan x divided by 1 minus tan square x whole divided by 1 minus tan square 2x means 2 tan x divided by 1 minus tan square x whole square. Now here you will get this as 4 tan x divided by 1 minus tan square x whole divided by, this is 1 minus tan square x whole square and this is 2 tan x whole square. So 1 minus tan square x whole square, here it becomes 1 minus tan square x whole square minus 2 tan x whole square whole divided by 1 minus tan square x whole square. we can cancel 1 minus tan square x and 1 minus tan square x. Now remaining 1 minus tan square x can be shifted to the numerator. Then it becomes 4 tan x 1 minus tan square x whole divided by. This is in the form of a minus b whole square, which can be written as a square 1, b square becomes tan power 4x minus 2 tan square x. And here we have 2 tan x whole square, which becomes 4 tan square x minus 4 tan square x. So this is now 4 tan x into 1 minus tan square x whole divided by 1 minus 6 tan square x plus tan power 4x. So this is tan 4x. So using the multiple angle formula of tan 2x, we can derive tan 4x. Next question. Cos 4x is equal to 1 minus 8 sin square x cos square x. So as I have taken tan 4x as tan 2 into 2x, here also I will take cos 4x as cos 2 into 2x. Now here I need the term sin and cos. So when I need the term sin and cos, I can express cos in terms of sin. So therefore, I know the formula of cos 2x as 1 minus 2 sin square x. So that's why I will write this as 1 minus 2 sin square x. Here x is 2x. Now we have sin 2x here. Use the formula of sin 2x. What is the formula of sin 2x? It is 2 sin x cos x. So 2 sin x cos x. Since I have square them. Next I'll get 1 minus 2. 2 square is 4. Next I have sin square cos square x. So this is equal to 1 minus 8 sin square x cos square x. So this is our cos 4x. So here conversion becomes very important. This can also be expressed in many more identities, but this is one of the identity of cos 4x where we can derive using cos 2x formula. Next, we have here cos 6x is equal to 32 cos power 6x minus 48 cos power 4x plus 18 cos square x minus 1. All the terms in the right hand side are in cos. So when you are getting cos xx, when you get any other term like sin or tan, just convert it into cos only. Now I will take cos 6x as cos 2 into 3x. I'll use the formula cos 2 into 3x. So cos 2 into 3x can be written as cos only, like cos 2x as 2 cos square x minus 1. So that's why I will write this as 2 cos square x is 3x here minus 1. But I know the formula of cos 3x as 4 cos cube x minus 3 cos x. So in the place of cos 3x, use 4 cos cube x minus 3 cos x. So then you will get 2 4 cos cube x minus 3 cos x. We have square here, so whole square minus 1. Use a minus b whole square formula here. So then you will get it as 2. A square is 4 cos cube x whole square plus b is 3 cos x whole square minus 2 times a into b is 4 cos cube x into 3 cos x minus 1. Just expand the terms now. 4 square is 16. Cos cube square becomes cos power 6x. Next, 3 square is 9 cos square x minus 2 4s are 8. 8 3s are 24. Cos cube x into cos x is cos power 4x. So outside you have 1. Multiply 2, then it is 32 cos power 6x plus 18 cos square x minus 48 cos power 4x minus 1. So this will give you cos 6x. So 32 cos power 6x plus 18 cos square x minus 48 cos power 4x minus 1. So again here also using cos 2x formula by taking x as 3x and then expanding it using the formula of cos 3x, we can derive the identity. So these are few proof for the identities of multiple angles in terms of cos, sine and tan. So other than multiple angles, we have also have submultiple angles. So what do you mean by submultiple angle? If we take an angle as x, then angle x by 2, x by 3, that is the angles in terms of fractions are called as submultiple angle. Since we know the standard identities of all multiple angles of 2x and 3x, we can rewrite them in the form of submultiple angle. For example, we know the formula of cos 2x as cos square x minus sine square x. So if I take the conversion of 2x in the place of 2x, if I replace by x, that is half of 2x is x, then half of x is x by 2. Therefore, we will get cos x as cos square x by 2 minus sine square x by 2. So this is a half angle formula. So we can also call them as half angle formula, which is in the form of half of the given angle. Similarly, we know that sine 2x is 2 sine x cos x. So that's why what is half of 2x? It is sine x. Then this can be written as half of x is x by 2, which can be written as 2 sine x by 2 cos x by 2. Hence, all the multiple angle can be reduced to half of the given angle or 1/3 of the given angle. So the same formula of cos 3x, which we will write it as 4 cos cube x minus 3 sin x, can be written in the form of cos x as 4 cos cube x by 3 minus 3 sin x by 3. Because we have taken 3x as x here, so therefore x should be written in the form of x by 3. So the angles written in terms of fractions are called as submultiple angle, and all the multiple angles can be followed by the same identity for half angle, also 1/3 of the given angle. So these type of angles are called as submultiple angles. Next, we will get transformation formula. So transformation formula we obtain by adding two identities of compound angles. So that is, for example, when I add cos x plus y and cos x minus y. So we know cos x plus y is cos x cos y minus sin x sin y. And cos x minus y is cos x cos y plus sin x sin y. So thus these two terms get cancelled, then I am left with 2 cos x cos y. So like this, when you add any two compound angles formula for the same function, so here I will take x plus y as some a, then x minus y as some b. Then this will give you the form of cos x plus cos y. Then what about x and y here? Since I have taken x plus y as a and x minus y as b, I will get x in the form of a plus b by 2 and y in the form of a minus b by 2. So this formula has been generalized in terms of x and y. So whenever any two function in the form of cos x plus cos y or sin x plus sin y or sin x minus sin y, it can be converted into the product form. So for better evaluation of trigonometric function, we will use this transformation formula. So which helps us to simplify the values of trigonometric function more easier. So that is why, remember here, cos of x plus y is completely different from cos x and cos y. So here you are taking the same angle for one function. So here cos x and cos y are separate. So that's why cos x plus y is completely different from cos x plus cos y. Hence, these are the transformation formula we obtained by adding two compound angles formula of the same function. So now here cos x plus cos y is 2 cos x plus y by 2 cos x minus y by 2. Cos x minus cos y is minus 2 sin x plus y by 2 sin x minus y by 2. How we get minus here? If I take minus here, then the first two terms get cancelled. The second two terms will remain same. So we will get minus sin x sin y minus sin x sin y, which is minus 2 sin x sin y. So thus x and y is written in the form of a plus b by 2, a minus b by 2. So in general, we will write it as x plus y by 2, x minus y by 2. Similarly, sin x sin y can be written as 2 sin x plus y by 2 cos x minus y by 2. Add sin x plus y and sin x minus y. You will get 2 sin x cos y. So sin x cos y is in the form of x plus y by 2, x minus y by 2. Similarly, when you subtract this, this is what you will get. So this is the transformation formula of trigonometric function from sum or difference to product. The same transformation formula can be reversed here. So clearly see here, the product can be reversed to do sum or difference again. So if you want cos x and cos y, then you can write this as cos x plus y, cos x minus y. 2 goes here, so it will become half of the sum of the two function or difference of the two function. Thus, the product can also be converted into sum or difference of trigonometric function. Thus, we will get cos x cos x into cos y as half of cos x plus y, cos x minus y. When you add these two identities, you will get this value along with 2. So therefore, if I need only this, then you need to divide it by 1 by 2. Again, here we have sin x into sin y, which is obtained by subtracting these two identities. Sin x cos y is obtained by adding sin x plus y and sin x minus y. So half if necessary here, because the function is 2 times sin x cos y. If I need only sin x cos y, then this is half of the sum of these two identity. Similarly, cos x sin y is given. This is half of sin x plus y minus sin x minus y. So these transformation formulas are very necessary while solving the trigonometric problems. So from the last previous sessions, we have learned the values, domain, range of trigonometric function. Also, few important allied angle property, compound angle identities, multiple angle identities, and here we have learnt the transformation of trigonometric function in terms of sum, difference to product, and product to sum and difference. So these are very important to solve any kind of trigonometric problems. Thus, the knowledge of the domain, range, and the sign of trigonometric functions in each quadrant, along with all the identities until these sessions are necessary. So in our next session, we will take up the problems on trigonometric function and let's solve it using all these identities and formulas. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.